function. All right, coming to you live. No. So we've already done the review. I'm just make sure we have this in the video. We already did the review of what it takes to make a binomial. And out of 10 trials, 6 successes, the formula we have, we use this. Okay. Or we can use the binomial PDF function built in the calculator. I'm just going to add this in there to remind us that the binomial PDF, if we go to second and vars, that above that is the distribution menu. Oh, it's a video. Here we go. Second and vars. It's a distribution menu. We can go it either down or up in the list. Oops, not that way. To A, the binomial PDF, type the information, and calculate. Hopefully that, we'll have to see if that recorded the calculator. I think it did. I think it just does whatever on the screen. Okay? So, we're about ready to talk about using the other guy. Second distribution, letter B. Now, letter B on this has a C instead of a P. Go ahead, PDF versus CDF. Letter B in this binomial on this menu does a cumulative. It adds stuff up for you. Okay. So but the way it adds it up from a number down. Okay. So when I do letter B, which is the binomial CDF, that's cumulative. I don't know if I'm spelling that right. From X equals a number and down. If we wanted to go up, we'd have to, there's a couple different ways. It would depend on what kind of up we were doing. So we're not going to worry about up right now. We're just going to worry about down. So you're like, well, what do you mean down? I mean, like, X is less than or equal to 4. So if I do the binomial CDF with 10 trials of 0.7 and X equals 4, it's really going to do X equal to 4, 3, 2, 1, 0, and add them. So it's going to do exactly what this says with like a tenth of the work. I love stuff like that. So here we go. Binomial CDF. 10 trials. Move out of the way, guy. 0.7. 4 means 4, 3, 2, 1, or 0 if we're doing the cumulative. Paste, paste. 0.047. 0.047. Now, it's hard for me to kind of prove that to you unless we did the 4, the 3, the 2, and the 1, and we can absolutely do that, and I can show you that that gives you the exact same thing. All right, so why don't you try this one? All 25 students are going to shoot. X is 15 or less. At most 15 means X is less than or equal to 15. This is a good one to use the cumulative process, the cumulative shortcut, because otherwise we would have to do 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We would have to do all of those and add them all together. So let's see what you come up with there. Hey, if you didn't grab yourself a calculator, if you're like, oh, I didn't forget, run grab it right now so that you can do this. You can practice it. Make sure you know where the keys are. Okay. Got to pay close attention to the fact that you're doing one of them versus the other. Oops, not vars, second vars. And the cumulative distribution function with 25 trials, 15 or fewer making those free shots. So 15 or less successes. And if you do that right, it's going to be about 19%. It's hard on these to get a good idea if that seems reasonable or not. We don't have a great intuition. We people, not we, just you guys. We people don't have a great intuition for how binomial probabilities work. Okay. So, you know, if that's, you're like, that seems right, it's hard to know. We would have to look at the whole picture, the whole table of all the probabilities for 25. I think that, oh, wait. Okay. I think what we use, if you're trying to think like, well, how did people do this before when there wasn't a calculator? They would have to look it up on a table. So you would look up a table, see if I can find one. Because that's what I was trying to remember. Because when I learned this, we weren't, as a college student in statistics, people didn't have graphing calculators yet, at least not everybody, at least not most people. Early 90s, right? Early 90s, this wasn't like a thing. We just had regular calculators. So I think it may have been built into our scientific calculator some way. I can't remember, but I'm pretty sure. Let me see if I can find one. Oh yeah, there it is. You guys are gonna be like, what? This is like changing the channel on the TV without a remote, right? It's like, so you would have to go to a table like this. The probability of success, and then the number of trials, and then R is the number of successes. So you would have to look at a table like this where somebody had already done all the calculations and you could figure it out that way. I really wish I still had my stat notebook from college so I could look at some of that stuff. So,